Everybody, my name is Pete Gordon, and I am thrilled to kind of introduce this event and to talk to you about large language models and get us kind of started here, if you will. I am super sorry and regretting that I am not there in person. I had stayed safe and sound for a couple years, but just in the past 48 hours, it hit me hard. And watch out for the COVID. So again, I am so sorry that I'm not there, but I'm excited about this day, and I'm excited about what you guys are going to build with large language models. I'm with GDG Columbus and Ohio Dev Fest. Been doing this thing for a long time in Columbus, Ohio, and really enjoy it. And am thrilled to be putting on this event with Columbus Code and Coffee and others. And I'm going to kick it off by talking about large language models, kind of the state of the industry out there from a programmer's perspective, and wanting to use APIs and wanting to leverage this. I'm going to give you some intro to it, if you will. Some intro to kind of the chat interfaces, multiple chat interfaces, and to APIs, and to embeddings. Now, how do I like to call those? I like to call those Pinky, the prompt engineer, and the brain of semantic similarity and embeddings and search, right? So that's what I'm going to do. I'm going to kick that off and share that with you. Welcome again to the Google I/O Extended event. And I look forward to seeing all your projects at the end. So here we go. Let's take a look at kind of just chat interfaces themselves. I'm certain all of you have touched ChatGPT from OpenAI and played with it. Hopefully some of you have actually seen the playground behind the scenes too when you sign up. This allows you to see not only the user prompt that you can put in here, things like, hey, how many planets are in the solar system, but also to make changes to which model you're using, the temperature, which the lower it is, the more direct and less randomness that's going to be there. The hotter it is, the hotter it's going to get with that creativity and adding to the words or the randomness of those words that appear in sequence after each other as they're generated, because that's where we get the term generative AI here with the large language models. And then over to the left-hand side, we've got our system prompt. And system prompts also referred to as context, but this is giving direction on, hey, give me a certain tone of voice, or use these types of parameters to kind of bring in how the large language model might respond to take into context as the system against each of the user's prompts, right? So this is a chat interface. This is a prompt interface. This is where you're at when you're dealing with prompt engineering. This is Pinky's world, right? Pinky the prompt engineer. And that's what he's primarily going to deal with. So how many planets are in the solar system? Well, there's 8 in the solar system. And here they are. So this is GPT 3.5. There's also a 3.5 16,000 or 16K, which is how many context tokens you can use on the in and the out. I think 3.5 Turbo here has 8,000 available, but you can use a 16K if you need more. There is a thing called loss in the middle, which gets kind of deep about context and Anthropic and their large language model called Claude has up to 100,000 tokens, but the loss in the middle kind of says that large language models have been trained such that they tend to focus on the first part and on the last part. They lose much of the context in the middle as the context area or size grows. So something to be careful of and be cautious of as we are all learning more and more about how large language models work from a statistical perspective and in context prompting, let alone fine-tuning and supervised fine-tuning, which I'm not going to talk much about, but I may mention it just like I just did. And then let's come over to, for example, the Vertex AI stuff, which is where the Palm API is inside of Google Cloud's environment. And this, you'll see, is very similar. We can choose models, meaning our our Chat Bison or the Chat Bison latest model that we can use. We have our temperature right here that we can adjust just like the other one. We have our context and system prompt that we can make changes. And we can ask a very similar question about how many planets are in the solar system. And we're going to get a similar response because there's 8. And here's where it's right. And I'm going to show you an example of where it gets very difficult to be right for large language models. And there is a concept working with large language models called hallucinations, which I'm sure many of you are familiar with, that you have to be very careful of as you're interacting with large language models. Hallucinations tend to be where a large language model, because it's predicting that every next word, will sound as if it is telling you something very true and very factual, when in actuality it is not. It is being verbose in making up something that is simply and totally not true. And that happens a lot. And in the world of prompt engineering with Pinky, you will have to deal with hallucinations and factual content. And how do you determine factual content? That gets into some things related to the brain and embeddings and using your own sources. And it also branches out into the thing I just mentioned about supervised fine-tuning and training your model, where you actually impact the weights and the bias of the model and get from that your own model that you can call, which is on the very advanced spectrum of natural language processing and large language models. So there's an example. I just wanted to introduce you to both the OpenAI playground and the prompt environment within the Google Cloud Console for Palm 2 and the Vertex API. All right, Vertex AI. And that's that. So now I want to show you some open source and some similar things that are available in open source if you have not seen them yet. Llama 2 was released by Meta. It was actually leaked. The weights to the model were leaked. And then about 3 weeks ago, they released it under a commercial licensing that you can sign up and get approved for. And there is a 7 billion, 13 billion, and 70 billion parameter model. And all 3 of those are available up on HuggingFace that you can play with them and check them out. And you can even run them and create APIs against them. You do have to pay for them when you use them as an API, because you have to have them as an endpoint. And they're not a freely available inference API. But there are some that are available as an inference API, but they're going to be a little bit lacking. And I'm going to show you that in a minute too. But here's an example of Llama 13 billion chat. The reason I want to show you this one is because it actually shows the advanced options down here. The 70 billion parameter does not, which includes the exact same things that we just talked about, right? The system prompt right here that we can change, providing context just like we could in the Palm API and the Vertex AI area, and just like we could in OpenAI's playground area, where we could control the system prompt and the context. And here's the temperature that we can change and control also. So we can ask it the same question: hey, how many planets are in the solar system? And submit that, and we're going to get a response really quickly. Hey, great question, there's 8. And hey, here they are in a list. That's interesting. I hadn't seen this exact response where it listed. Maybe I don't remember doing it with this exact system prompt, but I think this is a default system prompt. So, and that's telling it to be very helpful and respectful. So that is the Llama 13 billion model, and that shows the advanced options. Let me just show you the 70 billion really quick too. You can kind of see the difference that I was talking about there, and the fact that the advanced settings are not available to me here on the system prompt. Now there is a way that you can control the system prompts and APIs and with what you're passing in, and it's the INST and SYS settings for Llama 2 that can be controlled in an API call to it eventually, if you want to get to that point. But you can start here. This is perfect, and you don't have to start to tweak the direct API calls until you're using what's called an inference endpoint on HuggingFace and actually calling your own instance of a large language model. So there is an example of OpenAI, Google, Palm, and HuggingFace with, in this case, Meta Llama 2, of 3 different large language models, all 3 of which are incredibly high scoring in their usefulness compared to one another. And I think I might have kind of the LLM leaderboard up here somewhere. I don't have it right away, but I'm going to be able to get it and just kind of show you where those fall. There's also one that is the chat interface itself, which is kind of a really interesting one to look at and keep tabs on as a leaderboard. So highly recommend that. Chatbot Arena, this is it. And we'll load that up here and take a look. There's GPT-4. There's Claude I mentioned, which has the 100,000. There's 3.5 Turbo that we just used. There is Palm Chat Bison that we just used. And there's the Llama 2 13 billion chat. So that's just going to give you an idea of where they're falling on this leaderboard. This uses an LO rating, which gets deep into how large language models are scored and how they rank against one another, and these other two scores, and the licensing that is on each of those, right? The Llama 2 community being that that new one you have to sign up for now. And let's, so I showed you open source, I showed you OpenAI, I showed you Google for working with a chat interface. Let's move on to talking about some code, because that's what we're here to do, is we're here to do some software and to do some programming. So there is a repository out there that I call Pinking the Brain LLMs, and in that I'm going to simply show very small, very hopefully obvious interfaces for both the chat interface and embeddings. And I'll talk about embeddings more in a minute, but let's first talk about chat, because that's what we just demonstrated from a UI perspective. So we did OpenAI, we did a chat about how many are in the solar system. So here is an example, and with this I have an OpenAI key that I'm using in my environment variables, so it knows what to pull up. And I'm going to run Python 3 on this one, and I'm going to run Pranky Palm chats on the OpenAI stuff, and if all works well for the demo situation here, there it is in real time. There are 8 planets in the solar system, and here they are. And then I'm going to hit the same thing, and if you're looking at the code here, you can see how simple this is with the OpenAI chat completion create. And then I'm going to go over to Google. Will do the open source one last, just for the fun of it. The open source one, I'm going to hit a different model. In this case, I'm going to hit GPT-2 on the open source, but we'll get to that in a second. So here's the same idea. In this case, we are actually doing some context in here, because I just went ahead and left it in with the prompt. But you can see the chat send message here with the prompt, and these parameters, which include the temperature, like we just were talking about, are very similar. And the simple one function call, which gives us the chat interface for Google. And there's that one, and we'll give that one a call. And hey, how many planets are there in the universe? And there are 8 planets in the solar system. So sounds good. I think I agree with that. So now let's talk about open source. This one's fun. This is what's called the inference API. I'm not using what's called an inference endpoint for this yet, but I may show an example of that later. This is the inference API. Inference API is very limited in terms of which models are available to you to run. So this is hitting the GPT-2 model. With the inference endpoint, it's fully available to you. You can run any models, but it's a little pricey because you have to run them and you have to keep them running, and they charge on a per hour basis. They use GPUs, and they're kind of expensive in the dollars per hour kind of range. So this one I'm going to just demonstrate really quick as a GPT-2, and then we'll start to see things kind of going a little bit awry. Now remember, I wanted to show this example too, partly because it just gives us a taste of how far we've come. Now GPT-2 was available, I think, about 2.5 to 3 years ago. The original papers that kind of set all this apart were brought to us by Google, and it was a paper called Attention is All You Need. So I'm going to take a little bit of a break here, and I'm going to go back and just like share a little bit of the history with you on the natural language processing. So about 10 years ago, there was a thing called word to vec and sequence to sequence. And this kind of 2013. So this kind of came out of Google, and it came out of the research that they were doing in natural language processing, and they started to see vector space similarity happening between words, so that you could ask a thing like, the capital of France, Paris is to France as what is to England. And it would realize, hey, you're talking about a capital city and you mean London. And this came about because of this concept of word to vec and bringing about the similarity of words into a vector space, and then being able to navigate that for cosine similarity or cosine distance, which is the inverse of that, and be able to track words in that way. This happened about 2013, along with some other technologies around recurrent neural nets, things like long short-term memory, LSTM, long short-term memory, and these in statistical modeling, machine learning, natural language. This is two recurrent neural nets as an encoder and decoder, which was explosive in terms of how well translation could be done, particularly at first from English to Japanese, Japanese to English. And this also came out of Google, and this started the firestorm that then came another roughly 5 years later. It was 2017, I believe, which was this paper, Attention is All You Need, which is where the Google authors introduced the concept of transformers. And transformers is where we're at today, and that's why you have the T in GPT, and that's why we have things like BERT that came out shortly after this. But this is the life cycle of natural language processing, machine learning, and how it went from like sequence to sequence, word to vec, long short-term memory, into this idea of transformers and very large space of training set data on the internet. And that has taken us to where we're at today with GPT-2 and now GPT 3.5 and GPT-4 from OpenAI and Palm API, Palm and Palm 2 API, and I think they call it Lambda when they originally announced it at Google, and Bard that they make available as the chat interface too. So all of those words to say that there's a history here, and the history is about 10 years long in terms of natural language processing, going from sequence to sequence, deep neural nets, into transformers, which is even deeper, and attention is all you need in terms of neural nets, and then coming out into an interface like that we have today with a training set that brings in not only the base modeling that I'm talking about right now, but also then the supervised fine-tuning and training on top of that, and then also the reinforcement learning with human feedback, which is even on top of that. And that is what creates these huge models that we are seeing now and are super excited about. At least I am. So that's a history of large language models. Hopefully, a fairly quick history of kind of the papers, the research behind this. And then if I come back to kind of where I was at with open source, which is incredible that we're actually seeing this in the open source community too, I'm going to use the GPT-2 model, and we're going to kind of see it kind of fall on its face a little bit here, I think, if it behaves like it did when I did this earlier. And what happens is the answer is probably not too many. So, and what's funny about this is that you can actually duplicate something similar to this with a mask interface too in other like BERT models on HuggingFace, where it will tell you, hey, it will probably try to fill in the word with, what's the probability of, a ton or not too many or an infinite amount, and it doesn't have the discrete answer in this at all. So that's what I want to introduce you as a chat interface, and just kind of get your feet wet in all three of these areas, right? Again, OpenAI, Google, open source with HuggingFace and Meta, Llama 2. And then I wanted to actually share one with you that I really enjoy asking, which is an extremely difficult one. And it seems so simple, but it's not. And so I'll do it in the playground here. And we can go ahead and just ask what something like, what cities were mentioned during the 2023 State of the Union address? And I love this one because cities is a very difficult entity to try to determine. State of the Union address is pretty good. Like, that's pretty easy, and I'm sure this will get it. 2023, this is going to have a really hard time with that, and likely will tell you that it can't, right? And even as you go back into kind of the context and you say, oh, okay, well, how about then, and it didn't tell me there the year, 2021 is primarily when they stopped training. So let's go to 2020 and let's give it a shot at that point. Submit it. Hang on a second. Submit. There. And then you can start to see, this is fun because El Paso isn't mentioned actually multiple times in State of the Union address over the years. But what this is telling us here is these 7 cities were mentioned, and I'm not even going to bother to look this up or try to look this up because I'm going to tell you that they're mostly, if not all of them, going to be wrong. And this is a great example, in my opinion, of hallucination. And it is a very difficult problem to solve with large language models, but I want you to know this because it's really hard to get it right with large language models. So let's go back and we're going to ask Bard, or more importantly, the Palm API, the same questions. So let's go over here and let's hit this. See how it does. So there it hits the capital. I think maybe it blended these two together to try to get that. I have no idea. Let's see if it'll answer it again. What cities were mentioned during the 2023? Okay, so it was given then, all right? No, what cities were mentioned? Let's clear the conversation and let's find out what cities were mentioned. There we go. Okay, so clearing the entire context of the conversation, right? Now we have a whole bunch of cities, and I guarantee you that many of these are wrong. So, in fact, I think all of them are, in this case. Philadelphia might have been mentioned, I can't remember. San Francisco, actually, some will answer that it was mentioned. Now watch this, though. I'm going to clear the conversation. I'm going to change it, and I just saw this today for the first time, and I want to share this with you guys. I'm changing to the latest on the Bison version. Hey, this is the first time ever that I have seen a large language model, and this was as of today, right? So this is hot off the press, actually return correctly that Columbus, Ohio was mentioned during the 2023 State of the Union address. Cincinnati, Ohio absolutely was mentioned. It was a bridge, and was one of the steel workers there in 2023. In fact, Columbus, Ohio was not only mentioned in the 2023 State of the Union address, but it was also mentioned in the 2022 State of the Union address. So I'm sharing all this with you to say, hey, you know what? Hallucinations are real. And so you can see Columbus, Ohio is not mentioned here in the response, right? So that is wrong by missing it. Now, I'm saying this to say hallucinations are real, right? And we have to deal with them. From a prompt engineering, from a Pinky the prompt engineer perspective, we have to deal with hallucinations. Whether it's better prompting, whether it's using embeddings in our own data, whether it's actually going into fine-tuning and training a model ourselves. That said, they are getting better. They're getting better as time goes on, and they are getting better as they're trained in more recent time, like this Bison latest and that response there that included Columbus, Ohio. So I wanted to share that with you guys because that is some good news. I have been testing this exact question for months now related to large language models. And literally this week is the first time I've ever seen a large language model able to return Columbus, Ohio out of a State of the Union address, whether it be 2023 or 2022. In fact, if you're curious about it even more, there's a repository on my GitHub that goes into State of the Union address I did with a friend of mine, where we pull it out by named entities, not using large language models, and we actually counted which ones were mentioned in consecutive years. And there's actually quite a few, you'd be surprised, but it's really exciting that Columbus, Ohio was mentioned in 2022 and 2023. So there's where large language models drop down, fall on their face a little bit, don't show well, and people experience hallucinations. So that's it. That's what I got for chat interfaces. Now I'm going to show you a little bit on the API side. All right. So let's go over to that. There's a code base out here. Well, I actually already showed this for the GPT-2, and I showed you the chat interface. So now I'm going to talk to you guys about embeddings, all right? And I promise this is going to be it, and then I'm going to let you go, and you guys can go start building stuff, and it'll be awesome, all right? But let me explain embeddings to you, and why you even care about embeddings. So embeddings are used to find the point in vector space, right, equal to a set of unstructured text. So I take a string of text, a sentence or a paragraph, could be anything, a set of unstructured text. I throw that at an embeddings model. It brings back to me a vector. And that vector could have 300 and some floating point values in it, could have 1,500 and some floating points values in it. But when it brings that vector back, what that does is that gives me a vector value for unstructured text that I can start to compare to other vector values of unstructured text. And by doing that, I can do semantic similarity, semantic search, and it goes back to that word to vec thing that I talked about earlier in the history of natural language processing about 10 years ago. And this way you can actually do it with your own data, right? So let me show you the 3 APIs for that. And we started with OpenAI before, so let's start with OpenAI now. And just give you an idea, I'm gonna hit it with the same exact phrase about solar system, and we're gonna see that embeddings, OpenAI, and what you're gonna see come back is a 1,536 floating point vector equal to this string, all right? And I just like for people to see what the vector array of floating point values looks like and what this string looks like, because it starts to then, at least for me, it started to click, right? Okay, what does this mean? And then now I can start to compare that vector string using like cosine distance and cosine similarity against other vector strings. And this is how prompting works. When you take something that somebody prompted, here's an example from the open source side. This is using a thing called sentence transformers, SPERT library in Python. It's also talked about on HuggingFace's site. And they use 384 vector values. And you take a value from a prompt, you put it into embeddings, you get back a vector, right? Take that vector and you compare it using cosine similarity and distance against a whole bunch of vectors for text chunks out of your own document repository that already has been processed. And then you surface up what was similar, maybe like K2 or K5 or K10. That's how many results you would take. Take those results, add it to that prompt, and add it to the initial user prompt, and then put it into another prompt and have it summarized by the large language model. And it's a very common way to treat embeddings and to get that chat interface so that it is working with your own content. So that was the example from open source. And then the last one I'll show you is just embeddings from the Palm API. And I think it's like 768 floating point values. And here is the simple code for that. And you can see it's just get embeddings on it from the model. You can see the model they use is text embedding model. So these are different models, right? These are the models that are here. It's text embedding ADA 002 for OpenAI. And here it's all mini LM that's being used for the sentence transformer package. These are different models. They're not the large language models. They're the embeddings modules. So sometimes you can just choose to do something in sentence transformers and use that. There's a lot of people who believe that's the right way to go instead of using API endpoints for embeddings. But they're also up on OpenAI, and you can use that for embeddings. I just wanted to show it to you and open it up. I also wanted to introduce you to a project out here. This was a project by a friend of mine, and I was there too, last week at a hackathon in Granville that actually demonstrated the use of the GitHub API and Llama Index to do embeddings on a GitHub repository. And then when somebody goes into a discussion on that GitHub repository, they can type in a keyword on it and it will invoke the large language model to embed what they asked, the question they asked in the discussion, and then compare that embedding to the embeddings of the GitHub repository, and then find the most similar ones, and then call a large language model, in this case OpenAI, to summarize it and return it back. And this was an example of kind of a large language model hackathon entry that used embeddings and large language models last week, and I just wanted to share that with you guys too. So that is all I have, and that was what I like to call Pinky and the Brain. And Pinky is the prompt engineer, the brain is embeddings. There it is working in OpenAI, Google, there it is working in open source. You guys are gonna kill it and have a blast with all of those. So don't get frustrated. Just be here to have fun and learn and see what cool things we can build. If you would like more depth on this, next Saturday, a week from today when you're seeing this, I will be at Columbus Code and Coffee, and we will have a special session focused on pinking the brain. So come on out for that. Share your completed projects, share your projects that are not completed, and we'll continue to exercise these large language models and build great stuff together. So thank you again for coming. Have a great time. Sorry again I'm not there, but I am thrilled to see what you guys build today. Thanks everybody. Bye-bye.